Welcome back to another amp dyno video, and today is 4-channel amplifier time, and this time I have the Punch 200.4 on the bench for amp dyno testing. And here are the manufacturer's ratings. It's rated 25 watts of continuous power into a 4 ohm load per channel, all 4 channels driven, and 50 watts per channel into a 2 ohm load. Here on the side you have the RCA inputs. You can have 2 pairs of RCA cables into your amplifier connected. There are 2 gain parts, one is for the fronts and one is for the rears. You have 2 switches with crossover functions, so if you have the switch in center position, it gives you the full frequency spectrum. If you put the switch on the left position, you have a high pass filter of 120 Hz, and if you put it on the right position, you have a low pass filter of 80 Hz. Both filters have a slope of 12 dB. I believe this amplifier is from the year 2001. Here on the other side you have just the power connection for the battery plus the ground connector and the remote connector, and on the right there is a status LED which shows you if the amplifier is powered up or not. And on the left side and on the right side you have the speaker connections, and if you want to bridge the amplifier you have to use the outer terminals for bridge mode. The Punch 200.4 is connected to the power resistors, and I have bridged mono the fronts 8 ohms and bridged mono the rears 8 ohms. It means I test for continuous output power into a 4 ohm load per channel, all 4 channels driven into full power. Now I'm going to check the idle current. The amplifier is idling at 1.4 to 1.5 amps. Starting with continuous power test 1 kHz, 4 ohms, all 4 channels driven into full power. Biggest load for the amplifier's power supply. Oh, I get clipping, I go back. The peak voltage is 46.4 volts. With 46.4 volts I got an output power of 69 watts per channel into a 4 ohm load, all 4 channels driven into full power. That means 138 watts bridged mono 8 ohms. That's impressive. The amplifier almost tripled its output power into a 4 ohm load. Let's have a look how many amps the amplifier pulls out when all 4 channels are driven to full power. That's 29.9 amps. I calculated an efficiency of 67%. Continuous power test, this time with 50 Hz. Oops. With 50 Hz we have a voltage of 45.2 volts. With a 50 Hz input signal, the amplifier still delivers 65.5 watts into a 4 ohm load, all 4 channels driven, or 131 watts bridged mono 8 ohms to the fronts and also to the rears. Continuous power test 1 kHz into a 2 ohm load per channel, all 4 channels driven into full power. The amplifier delivers a voltage of 39.6 volts. With 39.6 volts the amplifier delivers an output power of 100.5 watts into a 2 ohm load per channel, all 4 channels driven into full power. That means bridged mono 201 watts in the fronts, bridged mono 4 ohms, and into the rears bridged mono 4 ohms. So totally a little bit more than 400 watts. Let's have a look how many amps the amplifier pulls out at 2 ohms per channel, all 4 channels driven into full power. That's 49.9 amps. I calculated an efficiency of 58.8%. Continuous power test with 50 Hz. 2 ohms per channel. Clipping. voltage goes down. Amplifier delivers 37.2 volts with 50 Hz. The amplifier delivers bridged mono 4 ohms, 177 watts into the fronts and also into the rears. That's 88.5 watts of continuous power with 50 Hz into a 2 ohm load per channel, all 4 channels driven into full power. Also dynamically, we don't have dynamic headroom, we have the same output voltage, 39.6 volts, so there is no dynamic headroom into a 2 ohm load. I adjust the time base for better view. I reduce the gain. Signal input gets fine-tuned now until it looks okay. Is it okay? Maybe I reduce it a little more. I take this one and stop. So now we have a maximum voltage of 43.2 volts. In this case we have 120 watts, almost 120 watts. It's 119.6 watts per channel into a 2 ohm load, all 4 channels driven, but the front channel is only driven to half. I will start a new continuous power test with the front gain completely to 0, set to 0. I will raise the gain up to maximum and see what happens. Now I put the gain of the fronts to the right. Half gain. Now it's going to get full gain. So full gain, we see we have lower voltage. You see this here. Just for demonstration. This is because of the capacitance of the power supply, a small power capacity. So we can crank up 120 watts into 2 ohms per channel, both channels driven. Now it's time to make the sound test. Just a hint for my subscribers, because I heard that they don't get notifications if I put out a new video. It's nice that you subscribe, thank you for this, but you have to hit the bell button as well to get notifications when I put out another video. Thanks for watching, see you next time.